We will be solving second-order differential equation. Start with filling all the coefficients that we know into the equation. So L is equal 5 over 3. Now R is equal 10. And if C is equal 1 over 30, that means that 1 over C is equal 30. And that is equal E of t, which is 300. Now I will simplify this equation by multiplying both sides by 3. So now it's 5 times second order derivative with respect to t plus 30 times first order derivative with respect to t plus 90. Q is equal 900, and now I will divide both sides by 5. Plus 6 dq over dt plus 18 q is equal 180. To solve second order differential equation, firstly, I need to create characteristic equation. In my case, this is m squared plus 6m plus 18 is equal 0. And I'm searching for m by using quadratic formula. So m is equal minus 6 plus minus square root of 6 square minus 4 times 1 times 18 divided by 2, and that is equal minus 6 plus minus square root of minus 36 over 2. I have to take square root of negative number. That means that my solution will be complex. Minus 6 plus minus 6j over 2, and after simplification that is equal minus 3 plus minus 3j. If characteristic equation have complex solution, that means that general solution of my function will have form e to the power real part of my solution, so minus 3t, multiply by constant times cosine imaginary part of my solution, so 3 times t, plus another constant sine, and the same argument, so imaginary part multiply by t. Our differential equation is heterogeneous one, therefore we need to find particular solution, and we will do that by suggesting that our particular solution is just a constant. So first derivative of that is 0, as well as second derivative that is also equal 0. We put the values inside the original equation. So we have 0 plus 6 times 0, that is of course 0. We end up with 18 times our particular solution is t, that is equal 180. Therefore, t is equal 180 divided by 18, which is 10. We are adding that into our solution, so our solution now has form e to the power minus 3t, a cos 3t plus b sine 3t, and plus particular solution, which is a constant. As a next step, we will be trying to find the value of constant a and b by applying initial condition. First initial condition we have is that we know that the value of our function q at time 0 is also equal 0. So we will put that into our equation. 0 is equal e to the power minus 3 times 0, a cosine 3 times 0 plus b sine 3 times 0 plus 10. e to the power minus 3 times 0 is e to the power 0, which is equal 1. So we have 1 here. Cosine 0 is equal 1, so we have a times 1. B times sine 0. Sine 0 is equal 0, therefore b times 0 is equal 0, so we have a plus 10. And from that, we can conclude that a is equal minus 10. To find the second constant b, we will be applying second initial condition. Firstly, we need to find first derivative of our function. First derivative of our function will be equal derivative of e to the power minus 3t. I'm calling that part u. So this derivative of that is minus 3e to the power minus 3t, multiply by the second function, I'm calling it v. So this is equal a cos 3t plus b sine 3t. Now I will take first function and multiply it by derivative of the second one. Derivative of cosine is negative sine, and I have to multiply it by the inside function. I'm using chain rule, so it's minus 3a sine 3t plus b. Derivative of sine is cosine, but again I need to multiply by the derivative of the inside function. So it's cosine 3t, and derivative of 10 is equal 0. I know that derivative of q at time equals 0 is equal 9. Therefore, I'm putting that inside my equation. 9 is equal minus 3. E to the power minus 3 times 0 will be e to the power 0. A cosine 3t, t is 0, will be cosine 0 plus b sine 0 plus e to the power 0 minus 3a sine 0 plus 3b cosine 0. Sine 0 is equal 0 here and here, so those values cancel out. E to the power 0 is equal 1. I have 9 being equal minus 3. Cosine 0 is equal 1, so minus 3a plus, and I have 3 times b, again cosine 0 is equal 1. I'm dividing both sides of this equation by 3, so 3 is equal minus a plus b. From the previous initial condition, I know that a is equal minus 10, therefore minus a will be equal 10. 3 is equal 10 plus b. b is equal 3 minus 10, which is equal minus 7. Now I can put my constant into my equation to find final solution. Q is equal e to the power minus 3t. A is minus 10 cosine 3t plus b is minus 7 sine 3t and plus 10.